Hello, my name is Zachary Brooks from UGenome. We make genomic medicine personal and accessible for everyone. So today I'm here with UGenome's Director of Products, Komal Sharma, and she's going to be talking about AI and decoding genomic insights. Komal, take it away.
Hi everyone, thanks, Zach. In 2003, sequencing one human genome costed $3 billion, and it took 13 years, the combined effort of all these scientists across 18 countries. Any guesses like what would be the cost now? It is around $400. And you can have, like, in $400, you can have your entire DNA sequenced and it arrives at your door. Think about that. We happily spend $400 on a device that counts our steps. For the same price, you can now unlock 3.2 billion base pairs of data about who you actually are. PCR-based testing, it looks at thousands of targeted markers, meaningful insights, but on the other hand, whole genome sequence reads all of it. Every gene, every variant, every story your DNA has to tell. Now imagine being sequenced just once, and having access to every genomic insight, your risk, how you age, how you respond to treatment, and rest of your life. That's one direction we are building towards. And Seek for Life is the platform we build to make every single one of those 3.2 billion data points actionable. But where's the biggest problem? The reality today is that most of the people have never been sequenced, not because they didn't want to, but because until recently it cost thousands of dollars and required a clinical referral just to get started. And for the ones who got sequenced, the few of those, they received a VCF file, hundreds of megabytes of raw genetic variants, no context, no explanation, no next steps. Imagine finally getting your hands on most important data set about yourself and not being able to read a single line of it. And this is just not a consumer problem, it's a medical one. Right now, over 90% of the clinical decisions are made with zero reference to patient genetic profile. This is a study published by Deloitte in Genomics England. Same drug, same dose, same treatment plan, regardless of whether your DNA says it'll work for you or not. We generate more genomic data every 2 years than we did in entire history of genomics. Now that's a publication which was published in that's a report published in Nature. And all of this data sits in a database, unused, uninterpreted, disconnected from the people it belongs to. We don't have data problem. The problem is with the action. So what do we actually need? We need a platform that takes the whole genome file, all 3.2 billion base pairs, run it through clinically validated pipelines, generate reports a clinician can act on, and make it accessible to everyone and anyone. We need something like Seek for Life, where you can turn your data into decisions with Seek for Life. Now, coming to the topic, which is AI in healthcare. You have heard AI a lot everywhere, especially with ChatGPT, Gemini, and Claude, all of these LLM models rising. I know everybody, for every product, every pitch, every headline, you see AI this, AI that. It has become more like an overused word in tech. But I want to do something different. Before I tell you what AI in genomics is or can do, let me show you what it already does for you in healthcare right now today. I can see a good number of people like earlier, when we asked, like, do you use AI tools? Everybody said, yes, we do. But how it is actually being used in medical or in healthcare, it is actually different. People, they want something which can be trusted upon, which can be relied upon. So before this, what AI has already changed in healthcare broadly, it refers to how it has changed in radiology. FDA-approved AI detects breast cancer in mammogram with accuracy matching with two radiologists reviewing together. In dermatology, a Stanford study found that AI diagnosed skin cancer more accurately than a dermatologist. Protein folding, DeepMind's AlphaFold solved a 50-year biology problem in months, unlocking drug discovery at a scale never seen before. In every one of these cases, AI didn't replace the doctor or the scientist. It gave them the ability to see more, faster, and with more precision than ever humanly it was possible. Now, let's take the same principle and apply it to the genomics. Your whole genome file contains over 6 million genetic variants. A human expert reviewing them manually would take thousands of hours per patient. When you get sequenced, what you actually see is just numbers. There are some characters like CHR 10, 9, 4, followed by some numericals. How an agent would read this is like how we read our general books and newspapers, the context behind that. It would rather say that you carry a variant in your gene, for example, CYP2C19, that affects how your body breaks down certain medications, including common antidepressants or any other medications which you have been taking or your body is not supposed to take. The same data, which is not readable by 99% of the world, becomes actionable to everyone. And Seek for Life runs this genome through clinically validated automated pipelines built from best in class bioinformatics tools. So you don't need a computational biologist in the same room to extract meaningful insights from your data. The output is a structured clinical report. Now, you might be thinking, I already asked ChatGPT my health questions. Why do I need something different? Like everybody, I think most of us, we might have put in a question in an LLM model, ChatGPT, Gemini, or Claude, before visiting to a doctor about our health conditions or how we are feeling or the medications we are taking. But do you know whether your data is safe or not, or whether or not you should be adding this information in an open source model? What's the problem? Here's the difference. When you type in your symptoms or medications into a general AI tool, that conversation can be logged. It can be used to train model. It can be processed on shared infrastructure. And you have no idea where this data goes. Our agent is different. Every conversation is private, encrypted, and never shared externally. The model is not a general purpose AI, it is pre trained specifically on medical and genomic information. It doesn't know about the pop culture and the recipe ideas. It only knows your DNA and the information which is present in the DNA. And that's what makes Seek for Life different. Seek for Life is a next generation sequencing data platform built on one purpose for one purpose to take raw genomic data insights and turn it into clinically actionable insight that can be acted upon. The platform is organized into three suites. One is genomics, transcriptomics, and third is epigenomics. Genomics is about your DNA, the fixed blueprint you were born with, which is active. Transcriptomics, on the other hand, is the genes which are switched on right now in development. Epigenomics is how your environment modifies gene expression in the development. On our genomics, we have three different pipelines which are active. One is pharmacogenomics, HLA typing, and germline analysis. How to read these different pipelines, how to process your DNA, we will see it now after this in the demo. But in short, if I have to explain, genomics is the book you were born with. Transcriptomics is the chapter you're reading right now. And epigenomics is how your life has been editing the margins. Now, let me show you how it works in action. So for you, what you have to do is go to our platform, which is seekforlife.com. And once you go to seekforlife.com, you'll see an option to hit free trial. Click on that. You will be directly taken to our application where you can create your account for free and use it for free as of now. Now, on this platform, what you see on the homepage are the three different pipelines I was talking about: genomics, transcriptomics, and epigenomics. We have multiple pipelines coming up, but for now, we have PGX, which is pharmacogenomics, HLA typing, and germline mutation. And right here, you see the icon of our agent, which is our bot. On my dashboard, there are a couple of files which I ran in past as samples, so I'm going to start with this. But what happens is, for example, I am asking this bot, if you are not running a file on our platform, if you have an existing file, you can directly attach that file here and you can upload it. I do have a file pre-downloaded. I'm going to attach it and show it to you. So this was a test file. Propex is our proprietary name and tool under PGX for pharmacogenomics. Now, let's say I attached my report and I am asking, um, can I, oh, can I take tramadol? Let's see what it takes. It takes a couple of seconds to give the response because it's spanning through the entire file and referring it back to the database. Now see, based on your pharmacogenomic report, your CYP2DIX genotype is *5*5 allele. Again, it is like a jargon. I don't know what it means. But in short, how it explains is, which classifies you as poor metabolizer for this particular drug. That means if I take tramadol, if I have been prescribed with tramadol, it can actually cause toxicity in my body. And that's how AI can be used in genomics to translate all the complicated information into simpler, easy, digestible terminologies, which lay people like us, we can understand. And once I log out of the system, I reload, it resets. My conversation is not being logged. It was only for the time being when this was present and not beyond this. And that is why the agents, which are particularly deployed on platforms like this, are safer to put in your information and to query through it. So that's how we started talking about turning the DNA into decisions. And you have just watched what happened with your file, how you can extract your genomic information. If you have a whole genome sequence, you can always go to Seek for Life and get your pharmacogenomic, your HLA typing, and your variant caller files from here and chat with our agent, which is present on our dashboard, to know more or to know what information is present in your file. Thank you very much.
Kamal, thank you so much. So if you have any questions, all the information will be in the post on how to connect with UGenome, me, or Kamal. Have a good afternoon. Bye-bye.